Hello guys, this is a blue LED. Let's see. You can see the forward voltage is 2.6 volts, right? Let's look at this. A standard blue LED has 2.6 to 3.6 volts. That is an average of 3.0 volts to turn it on, all right? So let's look at what next. Okay guys, I've connected this to my bench power supply at 1.05 volts, which is 1 volt. And if you look at my oscilloscope, let me zoom a bit. You can see it's showing an average of 9, which is about 921 millivolt, right? So this is what I'm going to do. This is it. I'm going to increase the voltage. Let me take it back to this. So let me increase the voltage and let's see. At 2.5 is trying to come up. Let's take it to, you can see it's all right. Now let's look at our oscilloscope. If we are to take a zoom, you discover that it's showing a straight line, right? So this is a DC signal. So this little stuff we are saying is more like, noise, all right? So the average voltage is 3.03 volts, right? And it's turning on. Okay. Now you can see I've added meter to this. You can see the meter is showing 1.43, 1.41 from the power supply, and the average is showing 1.30 volts. So let's work with the meter. Let me increase it. Okay, you can see the meter at 2.75 volts at 2. From the power supply. You can see the voltage, the LEDs has turned on, and if you look at the oscilloscope, it's showing an average of 2.68, and if you look at the waveform, it's showing a straight line, which is a DC waveform. All right, so let's see what will happen the next phase. One thing I want you to note before we go to the next phase is the LED we only turn on, it didn't turn on at 1.7 volts. Do you get? It didn't turn on at 1.7 volts. You can see it. Then let's see until it gets to 2 point something volt before it's going to turn on, right? It didn't even turn on at 2.1 volts. It turns on at about 2.5 volts. Let me take it. Now, if you look at the meter, it's showing 2.5 volts. Our power supply 2.57, and this is my LED, right? Now let's go to the PWM signal. Why this is very important. Okay, I've connected this thing to a PWM signal from an Arduino microcontroller. Now you can see my multimeter is showing almost 0 volts, which is 2.6 millivolt. It's nothing. You can see my oscilloscope, the average volt is still 0. And from this serial monitor, I'm getting 0 as well. So let me give it a value of, let's see. Now you can see the serial monitor is showing 0.2 volts. Here is showing about 140 millivolts, and the average is still quite a bit low. So, but you can see my LED is turning on, right? But what you should look at, if you look at the waveform, it's not a straight line, right? Now let's see something. You can see the maximum voltage is about 3.3 volts, and the minimum voltage is negative something. So if we have to do plus and minus, it's about 4 to negative something. Okay, Let me increase the value. Now you can see the LED is, the average voltage is 0.64, and you can see the waveform. Okay, let me give it a more higher value. Let's say, now you can see the LED is turning on better, 1.904, and look at the waveform. All right, now let me give it another value. Let's say, you can see the LED is becoming more brighter. What do we have here? 2.27 and this. All right, so let me give it the last value. You can see 2.5 volts, 2.5 volts, and this. But recall, when we are using the bench power supply, it didn't peak until we have a voltage of about 2.6 volts, right? Which is what is written here. Am I correct? Okay, let's see why it's like that. So this is, so if I'm to filter this signal that is coming, so that it can work like this bench power supply, this is where a low pass filter comes in. And what is a low pass filter? It's just an inductor and a capacitor that you get to work on the average, such that I can have something that is coming like from this power supply. If you understand what a simple low pass filter is, then you can design a buck converter, a boost converter, a flyback converter. And my goal is to design a flyback converter. To make it simple means to design something like this, a charger. So let's continue. So guys, I've connected my low pass filter to the LED right now. You can see the meter is showing 2.1 millivolts, which is almost 0 volts. The average voltage here is 0 volts. Now let me give it something like a value from the, now I have 0.85 volts. This, okay, let me give it, I have 1.53 volts. Now, but if you look at what has changed now, the signal has changed. Unlike before, we have a PWM signal, right, that goes up and down. But now, right now, this filter, with the help of this inductor and this capacitor, I've been able to filter the signal, right? Now, so let me increase the value now. Now, the LED has turned on. What are we getting here? 2.7 volts, 2.64 volt. All right. So what we are getting now is a clean signal, just the signal we are getting from this bench power supply. All right. So if you understand this principle, like what I said, you can generate your own frequency. You can design a charger. All right. So that is it. So let me give it maybe a bit lower voltage. 2.69 volts. You can see the LED is still turning on. Okay, let me reduce it again. You can see it very low, 2.4 volts, 2.this volts. Then if I reduce it a bit, it's going to turn off, right? Because the LED need about 2.6 to 3.6 volts. So that is it. The next project I'm going to do now is I'm going to work on, I have two projects in mind. So I'm looking at container orchestration for those who are into DevOps using Kubernetes. And I'm also looking at how we're going to design everything here, which is a flyback converter from start to finish using this basic principle. Thanks, guys.